All right, let's continue our two-way table. The second objective of lesson 4.4. I got two more two-way tables to look at with you. Number 2, and this is on page number 4. Okay, in the Senate of a particular Congress, there were 54 Democrats. Guys, as I'm reading this, I'm gonna go ahead and fill out the table that's given here, okay? So hold on. 54 Democrats. Let me write down 54 for the total number of Democrats. 54 right here. What else? 44 Republicans. So 44 goes right here. And 2 independents. Now, we're not going to use this number until I think the very last part. Because if you add 54 plus 44, you will get 98 right there. So this table, this two-way table doesn't have any independents listed. But we will use that number 2, I think, down here on F. Okay? Alrighty. So let's keep reading. Of the 24 women in the Senate, so what are they saying? They are saying that there are 24 women in total, right? They said 15 of them are Democrats. So I'm going to go ahead and put 15 in this cell for Democrats who are women. And 9 are Republicans. So 9 will go right here. So if you add 15 plus 9, you will get this 24, right? Okay, looking good. Now, that's all they gave us. But we should be able to find out the numbers for men looking at what we got so far. Okay, so let's find some numbers for men here. So knowing that there are 54 total number of Democrats, we can find the number of women by doing 54 minus 15. Okay, so how many men are Democrats in this particular Senate? This particular Congress. 54 minus 15 is going to be 39. So there are 39 Democrats who are men. And similarly, let's figure out how many men are Republicans. So let's do 44 minus 9. 44 minus 9 is 35. Now let's add 39 plus 35. 39 plus 35 is 74. I'm going to circle these two numbers. What if I add 24 plus 74? If I do 24 plus 74, 24 plus 74 comes out to be 98. And notice how this number matches this 98 right there. So this table is complete. We did a great job on it. Now, let's use these numbers to find some of these conditional probabilities listed on B, C, D, and E. And maybe F too. All right. So B, what percentage of the Democratic and Republican senators are Republican women? Now, I'm going to go ahead and highlight the part that comes after of, okay? Because that's going to be my denominator. Okay, look. Of the Democratic and Republican senators. So what I just highlighted in this like green color is going to be the denominator. So how many people are Democratic and or Republican senators? That number is going to be 98, right? It's just going to be 98. Are Republican women. So what's the number for Republican women? That's going to be 9. So let's find the percentage, okay? So do 9 divided by 98. Multiply this by 100 to make it into a percentage. 9 divided by 98 times 100 is going to be 9.2. So I'll round to the nearest tenth. The answer is 9.2%. Okay? So the next one. Among the women in the Senate. Okay, I'm going to highlight the woman in the Senate. This is going to be our denominator this time, the total number. So we know that there are 24 women in the Senate. In this particular, what is the percentage of Republicans? Now, they're asking for out of all the women in the Senate, how many of them are Republican women, right? So the number for the denominator and the numerator is again 9 because we have 9 Republican women here. So let's try 9 divided by 24 and multiply this by 100. Okay, so that's gonna be 9 divided by 24 times 100. I got 37.5. So 37.5% are Republican women out of all the women in the Senate. Okay, all right. C. Among the Republicans in the Senate. Okay, so how many are Republicans in this Senate? How many Republicans? 44. So this number will be 44. What is the percentage of women? Okay. And you know, here again, we're looking for out of all the Republicans, right? Out of all the Republicans. So how many of them are Republican women? Again, the numerator is just 9. They love to talk about Republican women here, huh? So 9 divided by 44. And then let's multiply this by 100. All right. So 9 divided by 44 times 100 is 20 point. And I'm just rounding to the nearest tenth. So the answer for D will be 20.5%. Okay, we're doing good. So, you know, when you're doing these problems, these conditional probability problems, as long as you can identify what the numerator is and what the total is, you know, this is the whole part over whole, then you'll be good to go, right? All right. Now they're asking E, why is the percentage of women who are Republicans? That's what they asked in part C. So the answer that we got in part C, not equal to the percentage of Republicans who are women. Now, I mean, of course, they're different because they were asking 2 different questions, right? But if you were to give them a reason, we can say, part C was about, I'll really write that. Part C was out of all the women in the Senate, and part D was out of all the Republicans in the Senate. So you see how they both used, they both talked about the Republican woman in the denominator, in the numerator. We were looking at 2 different, the total number of, just different groups of people in terms of the whole here, right? So part C was about talking about all the women in the Senate, while part D, the question was asking for out of all the Republicans in the Senate. So that's why the answers were different in C and D, because they were asking different questions, okay? All right, let's do the very last one for this table, including the 2 independents. Now, there were 98 altogether, Republican and Democrat, right? So if you add up those 2 more, we have 100 total, right? So we have 100 total. Which is more prevalent? Women among all 100 senators. So let's find that first. The probability of women among all 100 senators. Now, this is a probability notation that you will use more in Math 245 statistics class. But let me highlight this, okay? Women among all 100 senators. So this is what I'm about to find with you right here. That's going to be, out of 100, first of all, right? Out of all 100 senators, how many of them were women? Let's see. There were 24, right? See, there are 24. So let's go ahead and write down 24 over 100. Now, that's approximately 24%. And that's exactly 24%. Now, let's look at the second one they're asking about, okay? Or women among Democrats. Okay, women among Democrats. So, probability of women among Democrats. Democrats. Okay, ready? How many Democrats did we have so that we can put that as a total number? How many Democrats did we have? We had 54, right? And out of how many of these 54 were women? 15. So the fraction that we need here is 15 over 54. Okay, so let's write down 15 over 54. 15 over 54. And that's approximately what percent? Let's take a look. 15 divided by 54. If you multiply that by 100 and round it to the nearest tenth, you will get 27.8%. So what would you say? Which is more prevalent? Well, women among Democrats is more prevalent than women among all 100 senators. Why? Because 27.8% is greater than 24%. So that's it. That's it for page 4. That's it for our second two-way table. Let's go over the last one, okay? The very last one. This is about a test and whether a person has a disease or not. All right, let's read this. Suppose a test for a disease is 90% accurate for those who have the disease. True positives. So, okay, so this is bad because they have the disease, but at least their results came out true. So, someone who has this disease, they're going home with the paper saying, "Hey, I have the disease." So this is called true positive, and 90% accurate for those who do not have the disease, the true negatives. Now, this will be the very happy case, right? You don't have the disease, you take the test, and then the test comes out saying that you don't have the disease. So this is the greatest thing. So let's see the true negative. True negative number is right here, right? Test comes out negative when this person has no disease. So that's looking at 3,480 people out of 4,000. So if I just quickly want to convert that into a percent, they're saying it is 90%, but I just want to double check, you know. Well, in this particular data, it comes out to be 87%. So it's not exactly 90, but suppose, okay, so it's not exactly 90, but that's what they're claiming. Maybe this is the real data. Alrighty, let's keep reading. Within a sample of 4,000 patients, the incident rate of the disease is a national average. Okay, complete parts A through C below. A through C below. And there is D there too. Okay, we'll do D too. A through D below. Alright, let's look at the very first one. Use the entries on the table to determine the overall incident rate of the disease. So, how many people have the disease, right? How many people have the disease? What percent of the people have the disease out of 4,000? So out of 4,000, we're looking at the number of people with the disease, right? So 80 people will have the disease. So what I'm going to do is I'm going to do 80 divided by 4,000, and we're going to multiply that by 100. 80 divided by 4,000 times 100 is... well, 2, exactly 2. So we will say that the incident rate is 2%. Okay? All right, B. Of those with the disease, what percentage test positive? Now, look at the wording very, very carefully, okay? Now, they are saying all of those with the disease, okay? Out of all the people who actually have the disease, how many people have the disease? 80 people, right? 80 people have the disease. And out of those 80 people, what percentage test positive? Out of those 80 people, 72% got the result saying that they have the disease. So the percentage will be 72 divided by 80 times 100. Let's round this to the nearest tenth. 72 divided by 80 times 100 is, now that's good, 90% exactly. And that is, that's what they told us. That's what they told us in the very first sentence, that this test is 90% accurate for those who have the disease. So I'm glad we got the same number, 90% here. All right, let's keep going. Of those who test positive, all right, I'm going to go ahead and highlight this part here, okay? Of those who test positive this time. So how many people tested positive this time? So if you look for that number, this is the total number of people who tested positive. So 512 is going to be your whole, part of your whole. This is going to be your whole. What percentage have the disease? So out of these 512 people, how many people actually have the disease? 72. So let's go ahead and find that probability or the percentage. 72 divided by 512 times 100. Okay? 72 divided by 512 times 100 is 14.06. So I'm going to say 14.1. 14.1%. Okay? What does that mean? So I guess this is the thing. I mean, you went to this lab or somewhere and then they say, hey, you have the disease. I guess you shouldn't be too depressed about it, because out of all those people who get the test result that says is positive, is positive, only 14.1% actually have the disease. Okay? So what's this called? The other cases will be the false, how should I say, false positive. Did they mention the word? No, but so, okay, we'll go on. Compare this result to the one in part B. So B and C, let's compare these two numbers and explain why they are different. Well, in part B, notice, I think they're asking these questions because both B and C used the number 72, right? They both used the number 72 for their numerator. But notice their denominators were different. In part B, comparison was to those with the disease. Okay, that was a denominator for part B. Where here in part C, the comparison is to those who test positive. So if you have the disease, 90% chance that you will get the result that says positive. But just because you got a positive result, it doesn't mean that you have the disease for 19%, because there's only 14.1% chance that you actually have this disease, even though your test says that you have it. So what if, well, if that happens, then you have to just keep on going for more testing. Like that happened to me. They were testing me for like gestational diabetes the other day, guys. And they said, hey, Sue, you failed your first test. You must have diabetes. You have to do more testing. So, I went back in and did more testing and found out that I don't have it this time. Yay. So, that's just what it is. All right. I think there was part D. So let's try to look at that one too. Okay. Wordy here. Suppose a patient tests positive for the disease. Okay, so this person is a little sad now because, this person got a paper saying that, hey, you have the disease. Okay, as a doctor using this table, how would you describe the patient's chance of actually having the disease? Compare this figure to the overall incident rate of the disease. The chance of having the disease increases to, 14.1%, right? Because this person just got a result saying that they got this disease. So I got that number from part C right here. Given that the test was positive, compared to what was the incident rate that we just found. Incident rate was only, 2% out of everybody, right? 2%. So, this test said something, but I wouldn't stop there. After you get a result, initial test says that you got this disease, maybe you should go back and do further testing, right? Alrighty, so that's enough for 2A tables. I will be back tomorrow with 5.1 linear functions. But when we did finish chapter 4, chapter 4 goes over section 1, 2, 3, 4. So you are ready to take your quiz for this week. Remember, you do get 2 attempts, and your highest score will be recorded. That's all due this Sunday. What else do I want to talk about? Just the different things that are on your... I don't know if you guys actually check out this weekly agenda that I always type up for you. So week 11 my math up assignment list. This will be good. So after what we just went over, you are ready to do your 4.4 homework. Tomorrow you will see the 5.1 lessons posted. Excel homework 5.1 is all ready for you to go. The video is ready, the Google Slides are ready, and quiz 4, after watching or learning everything in chapter 4, you're also ready to do that, okay? Thank you for submitting the Canvas quiz for Monday's attendance. You will have one coming soon tomorrow morning for Wednesday's